First of all, you have to know that action potential is the other name for impulses. Here, and resting potential is when there's nothing happening, there's no impulses flowing. So here, the resting potential is produced and maintained by the sodium potassium pumps, and also potassium leak channels there in the cell membrane. That is first. What do these pumps do? Sodium potassium pumps channels, they send sodium out and potassium into the axon. You know what is the axon. And then for every 3 potassiums, let me get the diagram. For every 3 potassiums that get in, for every potassium that gets in, 2 potassiums will get in, and 3 sodiums will go out. You see, there's more positive going out. We said 3 sodiums going out, so that's why we see there's more positive outside, and there is only 2 potassiums getting in. You see, that's why we have the inside is negative and the outside is positive. Yeah, as we said that there is still potassium getting in. Why is it negative? Because of the potassium leak channels. Potassium leak channels will let potassium out. It will let potassium flow outside. So now here in the resting potential, it is at negative 70 millivolts. It is resting. There's no impulses flowing, and here we say the cell is polarized. This process of pumping potassium and sodium happens through active transport, as we learned before in year 12. Okay, we continue. So how will this action potential happen? Now let's say something happened. Maybe you got burnt, and this action potential will not happen unless the potential differences reaches between negative 60 millivolts or negative 50 millivolts. That is called at the threshold at negative 60 millivolts and negative 50, and they are between in there. If it reaches there, the threshold potential, then we can generate the action potential. The impulses is generated. We don't use here the word impulses, we're going to use action potential. If it is less than that, if it is less than negative 60, between negative 60 and negative 50, there'll be no action potential. Like, let's say it is at negative 65 or negative 70, which is the resting potential, there will be no action potential happening. Okay, let's use a little bit of the diagram. Here it is at thresholds. We can see here it's a threshold. At the threshold, there's no action potential happening. You see, it is straight. And then there is a stimulus, like let's say heat. You got burnt. And what will happen? The sodium volt gated channels will open. And what will it do? It said a sodium gates will open, and sodium ions will flow in. They're going to get inside. That's why we see it's becoming more positive. This is a positive feedback, because this thing, the volt is going to increase to plus 35 millivolts. Inside is going to be positive and the outside will be more negative. There's an action potential happening. Now this, when there is an action potential at one point, it's going to set up a citrus, and it's going to move from one axon to the other, from one region to the other, until it reaches to the effector, and it gives the response. And then how will we go back to the resting potential? Now what happens is, now since it is positive, the will try to give a negative feedback. A negative feedback is the one which is beneficial for us, so we're trying to get a negative feedback. Potassium channels will open and it will let out potassium ions. That means now they will lick until we at the outside we're going to have more positive than negative, and we're going to reach as negative 90 millivolts. That is not resting potential. Resting potential is at negative 70 millivolts, not 90. So what's going to happen now? Again, the sodium potassium channels are going to open, are going to pump potassium in, sodium out, and the potassium leak channels will pump potassium out, and it's going to go back to negative 70 millivolts as it was before, and it will go back to resting potential.